So I know I promised you last week that I was going to show you the install of the new South Array this week, but I realised that of course we hit the end of February, so it's time for the roundup of all the various statistics, which means that this is the last time I'm going to show you the old summary of our system, because obviously we've got a new array added. So this is the old summary. Let's show you what the system was up until about 2 days before the end of February. We have a 6.8 kilowatt peak array split east and west, so 3.4 kilowatt peak on each side, going into a GivEnergy battery system with a combined capacity of 14.7 kilowatt hours, so a 9.5 and a 5.2 kilowatt hour battery combined, and those are both going into a Gen 2 5 kilowatt hybrid inverter. We also have a Toshiba air-to-air heat pump system that runs our heating in the winter and cooling in the summer, and finally we have a Mixergy IHP integrated heat pump cylinder that runs our hot water, and Cat also has an EV, which is currently a Fiat 500e. And because there were only 2 days at the end of February when we had the new array turned on, I'm going to ignore any statistics from that and pick that up next month. So let's get to the other stuff. So I'm going to start with this chart, which is the temperature and heating load for February. Now, I thought we were off to a pretty good start at the beginning of February, but pretty quickly, within a few days, the temperature dropped, the sun disappeared completely for a solid 10 days, and we had this horrible overcast grey cold weather. So you can see that the average temperature was 2-3 degrees, something like that, for a huge chunk of February, which means that we actually used quite a bit of heating, and we had no solar generation to speak of to compensate for that. So yeah, we actually ended up using quite a bit of heating. And you can see the solar generation from the GivEnergy report here, basically very little through the same period of time. So yeah, not much solar to help support the heating. And I think this day here was when we actually had the new electrical work done for the new install, which means that we didn't really get any generation for February the 21st. The array was actually not turned on until the 27th, and ironically that was when the weather started picking up again. As you can see, the old array, this is the old east-west array, I say old, the original east-west array, started picking up towards the end of February, which was just in time for the new array as well. So yeah, it'll be really interesting to show you next month what happens at the beginning of March, because it's been a pretty spectacular beginning of March, but I'm getting ahead of myself. That's for next month. So that horrible cold weather was responsible for quite a high heating load, 540 kilowatt hours in total, well above the modelling that I did a few years ago. This blue shaded area here, you can see it's above one standard deviation. This old model, this blue shaded area, is going to get replaced with a new model, probably at the end of March, beginning of April sometime. And I know for a fact it's going to be a lot higher. Our new heating strategy of heating overnight means that we're using more kilowatt hours of energy, but overall it's costing us less because we're using less peak rate power, as I've described many times before. But yeah, it's continuing to work really well. The heating load cost us only about 9.3 pence per kilowatt hour on average. So yeah, that's pretty good, pretty pleased with that. And as for generation, you saw previously in the GivEnergy charts, it was pretty bad as well. Started picking up towards the end, so that we ended up with about 164 kilowatt hours, which is a little bit lower than the -1 standard deviation from the expected based on the PVGIS estimate. So yeah, a little bit lower than we would normally expect, but yeah, it's definitely picked up in March. And as for total consumption, obviously it's been dominated by the heating once again, 540 kilowatt hours, as I mentioned. The baseline, pretty much normal, 245 kilowatt hours. The EV, about 90 kilowatt hours, so pretty standard. The hot water, 62.8 kilowatt hours, so yeah, heading down a little bit as we move into the spring. The temperature is getting a little bit warmer, so the SCOP is getting a little bit better. The water is going into the cylinder slightly warmer than in January, so needs a little bit less to heat up. And obviously there were a couple of days fewer in February compared to January, so all that contributes to 10 kilowatt hours less than January. Yeah, no dehumidifiers once again. We haven't really needed them at all, and the towel rails 12.13 kilowatt hours, so pretty standard. And here's how that consumption is broken down into the peak and off-peak periods. So this is for the whole of the winter from October onwards. So February is this bit here, and you can see that cold, miserable period of the start of February is responsible for somewhat more peak import than I would normally expect. These yellow bars here, but we're still dominated by the off-peak, which is really good. And in fact, if you look at this chart for comparing against last year, this is just peak import now. So last year, the total peak import over the winter was 599 kilowatt hours. And this is the extra bit that we've accrued in February compared to the rest of this winter so far. But so far in this winter, we've only consumed 407 kilowatt hours of peak power. So just about 2/3 of what we consumed last winter, which is great. So our overnight heating strategy is certainly helping us to reduce the amount of peak import, which is reducing our total expenditure, which is brilliant. So in terms of how much that cost us in total, you can see our actual bill was £93.37 for February 2025. That's in comparison to £154 in January, and last year it was about £79, so a little bit more than last year because of that extra heating load. But because most of that heating load was off-peak power, it actually wasn't a million miles more than that, so that's great. But obviously a lot less than January, and the savings are pretty similar. £152 saved compared to what we would have spent if we'd had gas central heating and hot water, and Cat's car was a petrol car and not an EV, and if we didn't have the solar and battery system. Yep, I'm pretty pleased with that. It's a pretty consistent £151 saved compared to £154 in January, £146 saved last January, so pretty similar actually. Yeah, the equivalent cost would have been £245 if you compare that to last year of £219. So yeah, definitely a little bit more that it would have cost us, but overall we've still saved a decent chunk. So yeah, pretty good. And the rolling average, the rolling total 12-month bill is still hovering around the £1,900, and our average actual bill is about £274 for that 12-month period from the end of February last year to the end of February this year. So yeah, that's not too bad at all. So I'm fully expecting all of this to change significantly next month once we introduce the new South Array. Obviously, we are now doing this experiment where we're comparing a string inverter against microinverters, 3 panels of each. So yeah, very excited to start sharing that analysis with you. There's going to be quite a bit of detail in that, I think. So I'm not entirely sure if I'm going to keep it in this video or separate it out into a totally separate video to show the comparison. Maybe in this one I'll just do the summary values, and in a separate video I'll do more of a deep dive into that. So yeah, haven't quite decided yet, but I'm sure you will be excited to see all that nonetheless. But in the meantime, if you're not already subscribed, please hit that subscribe button. That really helps the channel out. Thanks very much for watching. Hope you found that interesting, and I will see you next time.